All right, so we're going to be doing the dynamic wall maze for this problem. And I'm having you do the first two levels, so create an algorithm which the robot solves one of these, and then create an algorithm that solves um, the maze without any project modifications. Let's just say that solves any maze. By using a logic loop. There we go. So that's what we're going to do. So if I'm looking at the code here, there's kind of two ways to do this. There's this way, that'll solve any maze. But if we're just looking at this and I hit refresh, notice how the dynamic maze changes each time. So I can like write a program for this one, like let's say I want to drive 200. No, sorry. First, whatever you do, you got to put the pen down. So, and you have to put a comment in with your name. Comment. So here I am, DB. So like for level 1, all I'm requiring you to do is like you drive forward, and so like I wanna actually turn left, and I don't really care how you go about this. You just have to get to the end. So I would turn left, and I'd go like 200, and then I'd turn right, and I'd go like 200, and we'll see how this kind of looks. Drive along, and then I go up, and I'm hitting it, so maybe I go over. Looks like a box is more like 250, so I'll say like 250 and 250. So, oh, you see, I hit refresh. Once you hit refresh, though, it changes the map, so you can't really mess up. Otherwise, you gotta loop around. So, like, I've got to look at all the maps and get this one back. So 1, 2, 3, 4, 5, 6, 8, 9. And it keeps changing. This is the one I was on, though. So you like got to loop around a certain, or I wasn't on this one. Which one was I on? I was on. I was on this one. So I'd have to reprogram to do this one. But you see, you gotta go through the maps a certain amount of time. So you kind of got to get it right the first time. Otherwise, you're gonna have to like loop around several times to kind of figure this out. And you see, I'd have to loop around to get it back to figure out the one individual map. So you got to kind of remember what it looks like. It's not it. That's it. And then, I'd turn left. And, you just kind of, you got to keep going through this whole process. So over 250, up 250, over maybe 250, left 250. So it looks like I got a bunch of this going on. I'm going down. So left, right, left, left. And we'll see. So like you slowly work your way through the program, kind of figure out where you need to be. So you can do it this way for number 1. I don't really care how you do it. That's the one. You just got to know which map you're on and keep coming back to it. So let's see how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think this is the 12th. There's either 11 or 12. So that's how many times you got to cycle through. And then you just keep doing it. Obviously, this way is not the right answer. We would want to go over here. But I just kind of wanted to show how to do that and cycle through. So I don't care if you do the first one that way or not. I really don't care how you get through your code at all. But we've got a bigger problem. And that is the second one I want you to solve with a logic loop. So the first things I'm going to do for this one are set my drive and turn velocities to be 100 because it's going to take forever. And you could solve the first one this way. That really doesn't matter. Put the pen down. I want the pen to be green. Okay. And basically, I want this to kind of run autonomously. So I want it to go until we see red. So what I'm going to say is, while we don't see red with the robot, it's going to keep doing whatever it's got to do. But as soon as it sees the red, it's going to stop. So I'm going to say, well, we are not having the front eye, not the front eye, the down eye see red. What we're going to keep doing is we're going to drive forward and we're going to drive forward. Oh, I don't want to do this. I got to put in an if then. So there are kind of two ways to go about this. So where is my if else? So if I do something, I drive forward for, I'm going to say 250, and then I'm going to turn right 90, or else I'm going to turn right, turn left 90. But this is the big thing, and there's different things we could put in here. So like I could put in here, like if the distance found an object, I could drive forward, but that doesn't make sense. If the distance is in millimeters, and we got to go through, if the front eye detects an object is near, we could set this up like this. Turn left, if not, drive forward. So let's see what this kind of looks like. So this is one way to do it. And it'll just kind of keep going. And every time it sees an object is near, it will go and it'll kind of try to figure out the maze. But if it doesn't see an object near, it's going to try the turn and then it's going to go forward. So this will go through and it'll run through the whole maze until it basically gets over here. So this is one way to run it. I'm actually going to duplicate this brick here. The other way to do it is, instead of doing this, we kind of flop this. And we could also run the program and say, if we detect a distance is closer than 260, like a distance is greater than 260, so like once we get within 260, we'll drive forward. But if a distance is less than 260, then we will turn to the left. So this will do the same thing in like the opposite fashion. So either one of these two blocks right here, these two if statements, will work. They're doing it a different way, but they're both acceptable. So like this one and this one both work. I could hit reset right here, and this one does basically the same thing, but in a different way. And like the robot's just going to keep going when you do this. So I don't really care which one you did. There's lots of ways for this to work. And then obviously at the end of the code, I can put stop driving or have it do something here. Because once it actually sees the red, it goes past this and looks for the next thing. So either one of those is an acceptable way to do things. Like right now, the robot is like kind of searching and it's going to get turned around and go all the way back. But that's of no consequences. This is actually probably easier than doing it the way you might be used to, which would be plotting out, because if you don't plot it out right, you are going to have to hit reset like 11 times to get back to the regular map. So let's see if our little robot can manage all the pitfalls and I think it will. I think it's going to turn before going all the way up into the corner. And really here with the right and left, those are interchangeable. You could do the left first or the right first. And either of these are interchangeable. I think it asks you to do it kind of this way instead of this way, but both are acceptable ways for the robot to function. And we're going to go all the way down that corner. We're going to go all the way back up. So this is how you would run the dynamic maze program. And just for kicks, you could do like level 1 like this and level 2 like that. That's up to you. Just remember you got to have code. And the code can't be the same for level 1 as it is for level 2. It's got to be different. So whether that means you're just doing level 1 with velocity or something, that's fine. Do you know what's funny? If you set it up for here to have a heading of 90, it'll go through this little thing and then it'll like take off randomly. Like if I just put this here, just drive forward right at the start and I hit stop and I hit start again, it'll take off right through there, and then who knows where it'll go. It's somewhere out in the ether, so you can actually get it through that little spot, but you do not have to do that. But it's funny because I've had it doing this, and then I like see a line go shooting down this way, and like I have no idea where it's going. So this is how we do the program, and it's probably just going forward infinitely in kind of a box right now. So I hope this was helpful. If you have any questions, feel free to reach out, and good luck.